If a circle has a center at -1, 2 and a point on the circle at -5, 5, what is the standard form of the equation of the circle? Let's plot -1, 2 and -5, 5. The distance between these 2 points is the radius of our circle. We'll create a right triangle on the grid lines and use the Pythagorean theorem to calculate the length of the radius. The standard form of an equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. The center of our circle is -1, 2, so we'll substitute these coordinates for h and k into our standard form equation. While the length of the radius was 5, r squared is 25, so we'll substitute that into our equation as well and simplify, eliminating double signs. The equation of our circle is x plus 1 squared plus y minus 2 squared equals 25. To get an idea of what this means on the graph, I'll start at the center and I'll go 5 units right, up, left, and down to complete the circle. If a circle has a diameter with endpoints at 7, -2, and -1, 4, what is the standard form equation of the circle? Let's start by plotting these 2 points and creating a triangle to calculate the length of the diameter. Remember that the diameter is twice the length of the radius, so if the diameter is 10, the length of the radius is 5. Find the center of the circle by locating the midpoint of the diameter. Here I've created 2 congruent right triangles with equal length legs, splitting the diameter into 2 congruent radii. You can also use the midpoint formula. Let's go ahead and count the radius in all directions to complete the circle so that we can see what we're working on. The center of our circle is 3, 1, and the value of the radius squared is 25. We'll substitute the coordinates of the center into our equation for h and k and r squared as well to complete the equation of the circle in standard form. In order to determine whether the point -8, 1 lies on a circle with the diameter endpoints at 10, 5 and -6, -7, we'll have to write the equation of the circle. The first thing we'll do is use the midpoint formula to locate the center. Next, we'll use the distance formula to find the length of the radius. Now we can write the equation of the circle in standard form, substituting the coordinates of the center and the radius squared into our equation. In order to determine whether a point lies on the circle, we'll have to substitute the coordinates of that point into our equation and verify that it creates a true statement of equality. Using the circle equation we created, we'll substitute -8 for x and +1 for y, and then simplify the left-hand side of the equation. If this value equals 100, that verifies that the point lies on the circle. If the left-hand side of the equation does not equal 100, then the point does not lie on the circle. In this case, the left-hand side equals 101. So the point -8, 1 does not lie on the circle. Now you're ready to practice on page 36 and 37 of your packet.